right, hello everyone. I'm going to work some problems from section 11.8, so give you guys a bit more idea on how these are actually solved. I'm going to go ahead and dive right in. Okay, so the instructions for these problems are defined interval and radius of convergence. Okay, it doesn't really matter whether the series starts at 1 or 0, the process is going to be the same. All right. So I'm going to do a ratio test. And remember, ratio test, I'm looking at absolute values, so I can ignore any kind of alternating negative signs. Okay. Okay, so this is my an plus 1 over an. And then I want to look at the limit of this. Okay, but first I could simplify it. And then I'm basically looking for all the x's that make this limit less than 1. Okay, and I would keep absolute value bars throughout because they're going to be important for the limit. All right, so I want this to be less than 1. Okay, so the limit of this thing, n plus 1 over n, is 1. So really, what do I want? I want x less than 1. Okay, and if absolute value of x is less than 1, what does that mean? It means x is less than 1, greater than negative 1. Okay, so this is my the first part of my interval of convergence. Next thing I need to do is I need to test the endpoints. I need to test -1 and 1 individually. Okay, so if I plug -1 in for x, let's plug x equals -1 into my series would become, I think I did this in the lecture video. Once we simplify, we get -1 to the power of 2n, n. Okay. All right, and so this is always 1. Okay, so really our series is just the sum of n. Is this series convergent or divergent? It's divergent. Okay, so we don't want to include x equals -1. Now I'm going to do x equals 1. Okay, so I plug x equals 1 into my series. Okay, then my series, I'll simplify that. It just becomes -1 to the n. Okay, does this series converge or diverge? It diverges, right? Both of these diverge by divergence test. Okay, so I don't want to include x equals 1 either. So my interval of convergence ends up being -1 to 1 with parentheses on both, meaning I don't include those points. And what's my radius of convergence? Okay, my radius of convergence is just half this length. Okay, so this has length 2, right? This interval has length 2. So half of that would be 1. So my radius of convergence is 1. All right, next up, this one, x to the n over 2n minus 1. So again, I do ratio test. Okay. Let's see, that would be x n plus 1 over, let's see, I'm going to replace this n with n plus 1, and I get 2n plus 2 minus 1. So 2n plus 1. Okay, then I'm dividing by an, and I'll get 2n minus 1 over x to the n. I'll keep the absolute value bars, simplify. Okay, and I want this limit, I want the limit of all this to be less than 1. The limit of this part is 1, right? So I need this part to be less than 1. So again, I need absolute value of x less than 1. So x is less than 1, greater than -1. And again, I test the endpoints. Now, this is going to be different than the previous one. Let's see why. So let's test the endpoints. X equals -1. I plug that in. My series becomes -1 to the n. Does this series converge or diverge? It converges, right, by alternating series test. Okay. If you got a problem, if you got problems like these on the test or on the final, you would still need to check all the conditions for alternating series tests. So what do we need? We need the numerical part, 1 over 2n minus 1 is decreasing. We need to show it's decreasing, and we need to show its limit goes to 0, right? Okay, so we need to check those. I'll let you guys do that on your own, okay? But it's convergent. Now let's try x equals 1. I plug 1 into my series. Now I have a different result, right? This is going to be a divergent series. I can do this by comparison. Again, I would need to show this. I would need to prove it. So I would compare this to the series, let's see, about 1 over 2n, okay? And then I could pull the 2 out of this, and it's the harmonic series, right? So this series would be divergent, so this series should be divergent by comparison. Again, we need to show that, okay? So what do I have? I have, when I plug in x equals -1, my series is convergent. When I plug in x equals +1, my series is divergent. That means my interval of convergence should be -1 with a bracket, 1 with a parentheses, okay? So that's my interval of convergence. My radius of convergence is still just half this distance. It's still, let's say the distance is 2, divide that by 2, and I get 1. Okay, let's try this series. Again, I do ratio test. All right, and I simplify all this. So simplifying this, I get this, right? Xn plus 1 over xn, that's x. 2n plus 1 over 2 to the n, that's 2. Okay, and then n plus 1 squared over n squared, right? So I want this limit to be less than 1, okay? When I'm working these problems, I always, I look for, especially at the ends, I look at what their limit is. If their limit's 1, I pretty much just ignore it. I want the overall limit to be less than 1. Okay, so I want the limit to be less than 1. If this part's 1, then I really just need to focus on this 2x, right? So I want 2x to be less than 1. Okay, absolute value of 2x. Okay, so let's, how do I get rid of the absolute value bars? Remember, if I have absolute value bars, I can drop them, but I need to add the negative on the other side. Okay, now I need to get x by itself. So I have this, right? X is less than 1/2 and greater than -1/2. Now I need to test the endpoints. So again, I want to plug these endpoints in. Okay, so let's do x equals -1/2. When I plug that in, my series becomes 2 to the n. I'll do the x now. 1/2 to the n, -1/2 to the n squared. Okay, so how can I simplify this? These have the same power, so I can combine them into one expression, right? And that actually simplifies to -1 to the n squared. Okay, is this series convergent or divergent? It's divergent by divergence test, right? So I don't want to include this endpoint. Let's try +1/2. My series is similar, but I don't have an alternating negative sign. Once I simplify, it just becomes n squared. Again, divergent by divergence test. So I don't want to include this endpoint either. So my interval of convergence is -1/2 to +1/2, parentheses on both. Radius of convergence, all right, what's this radius of convergence? The total length of the interval is 1. Divide that by 2, and I get 1/2. So my radius of convergence is 1/2. Okay, let's start seeing some harder, not necessarily harder, but different examples. So x to the 2n over n factorial, similar to the series, the power series for e to the x. So again, the process is the same. I just do ratio tests. I got to be careful with ratio test. When I replace n with n plus 1, the exponent, I distribute it, becomes x to the 2n plus 2. Okay, then I have n plus 1 factorial on the bottom. Okay, simplifying this, I get, let's see, x squared, right, times 1 over n plus 1. All right. Now I want this limit to be less than 1, but what's going on with this limit here? The limit of 1 over n plus 1 is 0. So no matter what x is, the limit of this is 0. Okay, so that 0 is less than 1. So my limit is always less than 1. Okay, so that, what does that mean? It means no matter what x I plug in, my series is going to be convergent. Okay, so when I have this situation where I have the limit is 0, okay, my interval of convergence is going to be all real numbers, which I write like this, and then radius of convergence would be infinity. Okay. Okay, let's try this series. So ratio test. Okay. Absolute value here. Simplify. I want this whole limit to be less than 1. This limit is equal to 1. Let's see. So I want absolute value of x plus 2 times 1/2 to be less than 1. Okay, drop in absolute value bars. I get this. Multiplying both sides by 2. I get this. Now I want to get x by itself, so I subtract 2 from both sides. Okay. Now I need to test, so this is my interval, I need to test the endpoints. Okay, so let's try x equals -4. Okay, when I plug that in, my series becomes, let's see, -2 to the n over 2 to the n times 1 over ln of n. So that becomes -1 to the n over ln of n. This is a convergent alternating series, right? Convergent by alternating series test. Okay, so I want to include that point. Again, I need to check the conditions for alternating series test. Okay, now let's try x equals 0. I plug x equals 0 in, and my series becomes 2 to the n over 2 to the n. That's just 1. And then ln of n. Okay, this is divergent by comparison test. We could compare it to the harmonic series. So divergent by comparison test. So I don't want to include this point. So my interval would just be -4 included with a bracket, 0 with a parentheses. What's the radius of convergence? I take this interval, the length of this interval, it's 4 units long, right? I divide that by 2 and I get 2. So my radius of convergence is 2. Okay, as an I think we've seen a lot of examples of the intervals, but remember there's that other possibility where the interval of convergence is just a single point. So I want to show you guys an example like that. So let's look at this series. Okay, I try my ratio test. Uh, when I do ratio, this is my ratio test. This is my an plus 1 over an. Okay, now I need to simplify. Okay, n plus 1 factorial over n factorial. That simplifies to just n plus 1. And then this, what does this simplify as? Just 2x minus 1. Now I want the limit of this to be less than 1. I want the limit to be less than 1. But what do I know about the limit of n plus 1 as n goes to infinity? Okay. This limit's going to infinity. So no matter what x is, it doesn't matter if, well, I guess there's only one point where this will work, right? If x is, let's see, if this term is anything other than 0, okay, let's say it's not equal to 0, then no matter what it is, the limit's gonna diverge, right? If this value is like 0.0000, 1,000 zeros and 1, okay, eventually the limit's still going to be infinity, right? Because as n gets just ridiculously big, this limit's going to infinity. Okay, so the only way this limit is not going to be infinity is if this term is exactly 0. Okay, so we would need 2x minus 1 to equal 0, meaning 2x equals 1, x equals 1/2. So when x equals 1/2, this term is going to be 0 and the limit is 0, because no matter what this n is, it's going to be multiplied by 0, and so the limit's going to be 0. Okay, but if x is anything else than 1/2, the limit's going to go to infinity or positive infinity or negative infinity. Okay, so this power series is only convergent at the point 1/2. So how would I write interval of convergence? Now, it's not really an interval, but I would write it like this. This is set notation, meaning this is the set that only contains the number 1/2, meaning our series is only convergent at this point 1/2. And what's the radius of convergence for that? Well, it'd be 0, because it's an interval with 0 length. Okay, so this is how we would write this solution. All right. Hopefully that covers all the possibilities you need to see. Let me know by email or web course message if you have any questions. As we get closer to the end of the semester, I'm more than happy to talk with you guys outside of regular office hours. So just let me know.